design, we have two techniques to determine the time of an algorithm, and these two techniques include number one, experimental approach. And the second is abstract approach. So we have to discuss these two approaches in details in this lecture. So the first approach that we have is experimental approach. What is the experimental approach? To determine the time of a given algorithm. So the basic steps that we have to follow under experimental approach includes write a program for a given proposed algorithm. So once you propose some algorithm, the idea is to write a program for that algorithm and run the program on a system. And then observe and compute the time taken by program to execute. So this approach is simple and straightforward. Fine. Where we have to write a program for a given algorithm and then run that program on the system. Thereafter, we have to observe the time taken by the program to run on the system. So this approach we can find the time of execution of the program by simply computing the difference of start time and the finish time of the program. So this approach has the benefit that it provides us exact time of execution for a given algorithm. So this approach is very straightforward and simple to perform. But there are certain limitations which is basically observed in this approach. And what are they? Let us understand them. The first limitation for the experimental approach to determine the time of an algorithm is that the speed of the processor affects the execution of program. So we can understand that how so good algorithm we can design, if the processor is not good, it wouldn't do the justice with the running time of the program. So this is the first limitation in the experimental approach. Then the second limitation that we basically observe here is that different programming language works differently on different platforms. So the idea is, whatever the programming language we choose to write the program for a given algorithm, that language works differently on different systems. So we have to make sure that whatever the programming language we are choosing, it must be compatible with other systems too. Fine. So for example, suppose one person, if you can say there is an algorithm that you have designed for a given problem, and this algorithm is going to be defined through some language, like suppose I have defined the language in C, but this language, this program, you can say we have defined a C program for this algorithm, but it is run on the different system. One is run on Unix, one is run on Mac OS, and one is run on Windows. So it is natural that the time of execution of this algorithm would be different on the different platform. So it is not the correct way of determining the time of running time of a given algorithm. So the best way is to choose a common platform to determine the efficiency of an algorithm, of a program of a given algorithm. Fine. And the third limitation that we basically observe in the experimental approach is that the complex size of input taken for given problem also affects the running time of the program. So while using this approach, we have to take certain measures in terms of which processor we are choosing. The processor speed must be good enough to run a program in an efficient manner. The second measure is that we have to choose such a programming language which is interoperable, that can work on any of the platform with the same time. And the third measure is that we have to make sure that we don't take so much you can say we don't choose a problem of so much complex size that it affects the program. But you know, it is very difficult to control these parameters, these factors. Fine. So this approach becomes totally fail when we are in a process to determine the time of a given algorithm. So we move to the second approach, that is the abstract approach, and let us take the idea how abstract approach help us to find out the solution.